Hi there, Algebra 1. We are working with unions and intersection of sets. Okay. Objective: to find the unions and intersection of sets. Union is everything that creates the two or more sets. Intersection is a set of elements that are common to every set. Disjoints have no elements in common. Symbols: the upside U sign is a symbol for an intersection known as and. U is a symbol for union. It is known as or. So you can have some from both kind of thing going on here. So in your left pocket you have a quarter, a paperclip, and a key. In your right pocket you have a penny, a quarter, and a marble. What is a set that represents the different items in your pocket? Okay, so you could draw a diagram of this. I'm sort of going to be doing it that way, I should say. So, in your left pocket, they do it a little bit different in the book. So, left pocket would be this pocket, so I'm going to put it on the left. I'm going to put it in a circle. You have a quarter. You have a paperclip. And a marble. Okay, in your right pocket, which is going to be over here, you have a quarter, penny, and this one should have been key. This is key, this is marble. Okay, so realistically, these can intersect a little bit and maybe have some things in common. So let's try to make it so we get a little bit more of an intersection phase here. Okay, the quarter is technically in both. They want to know what is a set that represents the different items in your pocket. So I said that what is a set that is represented? Going back to this symbol U, like or kind of like an N or an upside down U, is a kind of an and statement. U would be a or statement. So what I mean by that is it has to be in both. And means both of them. An or statement would just be one of them. Well, what's in your pockets? You have a penny. I'm trying to decide if I want to do it this way. You have a penny, so if you had to list it all out, so it would be realistically an or statement, like I said. So you'd have left, U, not quite a U, and R, in which case you'd have a penny, a marble, a quarter, but I don't have to list quarter twice. Okay, paperclip, and key. Those would be the 5 different items that I have in my pocket. Okay? On part 2 here it says write sets P and Q below in roster form. What is P, U, or U, Q? So P is X. And we can change that from a year ago. X is a whole number less than 5, y is an even natural number less than 5. So, roster form, you gotta remember what that is. Upside down U like that is an OR statement. So, it would be both of them. So, first thing you want to think of is, what could all the things be for P? Well, P is going to be 0, 1, 2, 3, and 4. Okay, Q is going to be even natural numbers. So being that they're natural, I think that takes out 0, so that's going to leave you with 2 and 4, I believe. Those are the only even ones, and also they gotta be natural. So those would be your two sets there. Okay? Now you need to list this in roster form, but both of these are in roster form right now. So we did the first part. This is roster form of P, this is Q. Now we want to do what is P and Q. Well, actually, it just happens that P and Q is going to be 0, 1, 2, 3, and 4 because it's everything in that set. So this is sets of unions. It's every possibility. Okay. So if you really wanted to put this that's labeled, you would go P union Q equals this. Okay? That is our first slide. Okay. What is A and, or what the upside down U? Which would be your intersection. So intersection. So what is A intersect B? Well, which ones do they have in common in this case? In A. Well, A, let's see, 2. So I'm going to go A intersects B equals 2 would work, 4 does not, 5 doesn't, 6 doesn't, 8 does. So for A, this would be my answer. Those are the only two that are in bold. Okay? Now you have A intersects C. C is odd whole numbers. Well, your odd whole numbers are going to be 1, 3, 5, 7. Okay? So, at that point, I don't think there's actually one that works. Because A is all even numbers, and we want odd. So A intersects C is going to be, there is no set. What is C intersects B? Well, C intersects B is going to be 0 would not work, 2 would not work, 5 would work, and 7 would work. Those are the only two that would work for that. Okay. Using a Venn diagram to show the number of elements. All 500 commuters poll. Some drive to work, some take public transportation, some do both. 200 commuters drive to work and use both types of transportation. How many take public transportation? So 200 commuters drive to work. Okay, and 125 use both types. So interesting thing we got going on here. So you have a Venn diagram, which you probably know from English. Okay? 125 do both. They use, they drive to work or take public transportation. Okay, it says 200 commute to work. Well, if they do both, they're still considered in this circle. So this cannot, what's in this circle cannot be over 200. So then we take 200 minus 125 and find out just 75 drive themselves. How many commuters take public transportation? Well, you have 200 here. Okay. So you have 200 total here. And there's 500 people that were looked at. So that means there's 300 over here. But 125 of them take the bus. At least what I'm thinking here. So 125 of them would also take the bus. So this would be 300 that just commute. Because this total thing has to be what, or equal 500. This is the only way it adds up to 500. You add this, there'd be 425 people that take transportation. Okay? Trying to think of anything else to go with them. I do not think there is anything else to go with that. So it'd be 425 people use public transportation. There is your homework. I thought there was going to be one more slide, but I do not see it. So that is your slides in general. There's your homework.